All right, so let's just move right along to the second question. So it's integrals. So these are just slightly harder than the ones from the first one. So what we have to do here is, you have to fiddle around with it until it is in one of those basic forms. So let me just do these one at a time. So A, well, you could just write down the antiderivative here if you're experienced, but to make it more clear for people who might still be struggling with this, let me do more of the steps. So you can break this integral down like this, and the same limits here, x squared dx. And what I'm doing here is I'm using the properties of the integral so that, it behaves really nicely, just like big sigma, because it's the granddad of big sigma. And right, so if you find that baffling, then the section of the textbook that you need to look at is the section on properties of the integral. So now the antiderivative is easy because we're in one of those basic forms. So let's go ahead and do this. So now this should be x to the fourth over 4. And the limits go from 1 to 2. And what happens here? I get 3 times x cubed over 3. And the limits go from 1 to 2. Okay, and so this time I'll plug in the limits so you can be reminded how this works. So first you plug in the top limit. So here that gives me 2 to the fourth is 16 over 4. And now I subtract what happens when I plug in the first, or the bottom number here. And I get this. So the reason this works is because this is using the fundamental theorem of calculus. Alright, and let's do the same thing here. Now 2 cubed is 8 over 3, and you take away what happens when you plug in 1, you get 1/3. Okay, and this is some number. I'm not interested in what it is, so I'm going to leave it like that. And you can leave it like that on the exam too. So let me push this down. Okay, and go to part B. So, all right. So for part B here, it looks like maybe you should use some advanced techniques like substitution, but you don't need it. You can just multiply this xn. So, you should keep in mind that this thing is really, that's x to the 1/3, right? And this one is x to the 1/4. And when you multiply n and x here, which is x to the 1, what's going to happen is that all these exponents are going to add. So I'm going to multiply this n, it's going to distribute like that, and then the exponents are going to add. So what I get here is x to the 1/3 plus 1, which is x to the 4/3. And what happens here is I get x to the 5/4. Okay, alright, so that's a little sub-problem. So since this expression that I've just been looking at is really the same thing as this, I'm just going to integrate this. So the limits go from 0 to 1, and I can just integrate this x to the 4/3 plus x to the 5/4 dx. And all this stuff stops here. Okay, so now unlike what I did in part A, I'm just going to go straight to the antiderivative, because we've seen that you don't have, you can break the integral down into two pieces across this plus, but that just wastes time. So let's just do it all at once. So what I want to do now is add a 1 to the exponent again. So now that's going to give me 7/3. And I have to multiply by 3/7. So the same thing as dividing by 7/3, whichever one you'd prefer to do. And I do something similar here. Now I add 1 to the exponent. So this is a 4. I'm sorry, my handwriting is so bad. It should be 4. Okay, and so I add another 1 to this exponent, and so when I add 1, that gives me 9/4. And I have to multiply by 4/9, or divide by 9/4, whichever one you prefer. And the limits here go from 0 to 1. Okay, so you can see that when you plug in 0, everything just dies. So now I have this really easy thing. I just have to plug in 1 because plugging in 0 gives me 0. So the answer here is 3 over 7 plus 4 over 9. So that's the answer, and I'll leave it like that. Very easy. Okay, so let me scooch this down. And let's do part C. And actually, you know, I know some people find this letter theta kind of scary, but it's just the same as x. And actually, this question is really easy because what you have here, secant theta tan theta, that's just the derivative of secant. And so the antiderivative of secant times tangent is just secant. So I can go right to the answer here for part C. The antiderivative is secant theta. And the limits go from pi over 3. I guess I should have started at the bottom. They go from pi over 4 to pi over 3. Okay, so this means that the answer is secant pi over 3 minus secant pi over 4. And if you keep in mind that secant theta is really just 1 over cosine theta, you can figure out these values by using your knowledge of what cosine does at these points. So let's not make too big a deal about this. If you don't know what those are, you should, but let's not get too freaked out about that. So if you plug pi over 3 into cosine, then 1/2 comes out. So this is going to be 2 because it's 1/2 turned upside down. And if you plug pi over 4 into cosine, then square root of 2 over 2 comes out. So what this is going to be is 2 over the square root of 2. Okay, great. So I will leave it like that, and that is part C. So scooch that down. Because you can pause this if I start going way too fast. So for part D, you could either use the substitution rule, which is fine, or you could split apart this fraction. And what I mean by that is square root of 2t is the same thing as the square root of 2 times the square root of t. And I think there's some caveat here, like they both have to be positive. But that's okay because the limit is going from 0 to 9, so I can imagine that t is positive. So great. Alright, so what I'm going to do is, this is just the same thing as the integral of square root of 2 times square root of t dt, and the limits go from 0 to 9. And of course, you know, you can bring constants outside the integral sign. So this is the same thing as square root of 2 times the integral from 0 to 9 of t to the 1/2 dt. Okay, now it's very easy to go right to the answer. So square root of 2 times the antiderivative here is t to the 3/2 because you add 1 times 2/3. And the limits go from 0 to 9. And you know that when you plug in 0, you get 0, so really the answer is just what happens when you plug in 9. So the answer is the square root of 2 times, this is kind of fun, what is 9 to the 3/2? Well, first you take the square root, which gives 3, and then you cube it, which gives 27. This is 27 times 2/3, and then, you know, you could divide out the 3 too, but let's not get crazy. And that's about it, right? That's all, A, B, C, D. So let me stop this video.